Alright, so this is lecture 17, page number 14. Now this is going to be a continuation of page 13, so this is the same exact question, but we are going to go ahead and continue with more information. So now what we're given is that we are given that the total cost function for the quantities is 1000 plus 0.25 q squared, and we want to find the profit function. Now profit in this case is just going to be revenue minus cost. So that's kind of easy to remember. So profit is going to equal to how much money we bring in, subtract off how much is it going to cost us. Alright, now we already figured out what revenue was from the last lecture, so let's go ahead and write that down. So from the last page on our lecture notes, we had that the revenue is going to be 1/2 q squared plus 120q. So that was what we found for number 2. Now what I'm going to do is I'm going to subtract off the cost, which is now given to us. And I'm going to subtract this off as 1000 minus, instead of putting in decimals and fractions mixed together, I'll just put them all as fractions. So I'll write that as 1/4 q squared. Okay. So now that's going to be equal to, well, let's see here. I'm going to have 120q, and I'll do minus 1000, and I'm going to put together the minus 1/2 q squared minus the 1/4 q squared. So you can think of this as, again, 2 over 4. So 2 over 4, negative 2 over 4 minus 1/4 is negative 3/4. So that's just going to be equal to 120q minus 1000 minus 3/4 q squared. Okay. And that's going to be our profit function. And typically you write that in decreasing order. So I'll write it as 3/4 q squared plus 120q minus 1000. Alright, that looks a lot better. Now, again, the same thing when we had with marginal revenue. Marginal profit is just a fancy way of saying what the derivative is. So let's take a look. First, I'll figure out what the marginal profit is. Whoops. Marginal profit, just the derivative of the profit function. So that's going to be equal to negative 3/4 times 2q, because the derivative of q squared is just 2q, plus 120. And the derivative of 1000 is simply 0, because it's a constant. So this is going to work out to be negative 3/2 q plus 120. Alright, now we want to compute the marginal profit when q is equal to 60, so let's do that. So when q is equal to 60, what we see is that marginal profit is going to be equal to negative 3/2 times 60 plus 120. So that's going to be 30 times 3, which is negative 90, plus 120 is going to be equal to 30. So what we see is that profit is increasing. It's increasing at a rate of $30 per unit. So for every unit we sell, we make an extra $30 when we have produced, when we're at production levels at q is equal to 60. Alright, let's take a look at what happens when q is equal to 80. When q is equal to 80, we're going to have the profit, marginal profit, at 80. Negative 3/2 times 80 plus 120. That's going to be 40. 80 divided by 2 is 40, times 3 is negative 120, plus 120 is 0. Now that, again, we have increasing, and so this is sort of a turning point that we can see. And this is actually also where profit, I'll just go ahead and jump right to the conclusion, profit is actually maximized. Now, and just to verify this, Let's see what happens when Q is equal to 200. So marginal profit is going to be 200, which is equal to negative 3/2 times 200 plus 120. So we have 200 divided by 2 is 100, which is times, so it's negative 300 plus 120, so it's negative 180. So here we see the profit is decreasing. Is decreasing by $180 per unit. Okay, so now let's actually figure out how to interpret, again, what these things mean. So we have, if I want to find the profit changes increasing from 60 to 61, the actual change, again, this is the actual change, is going to be equal to, and I give you the 61s, P of 61 minus P of 60, and so it's that minus that, which is equal to $29.25. Now, what's interesting is that you need a calculator to find actual change because the numbers are horrible. They're horrific numbers. But notice up here, the derivative of P at 60 was equal to $30 per unit. Was $30 per unit. So notice here that the approximation, again, this is per 1 unit. If you do this divided by 1, you get 29.25, and this is 30 per 1 unit. And they're pretty close, actually very close. This one doesn't need a calculator, but this one does. This, the actual change. And so again, this is your approximate change. Okay, let's take a look at the graph of this and see what we're actually doing. Alright. So what we've done is here you have your revenue function. So this is your revenue, R of Q. And this darkened line is going to be your cost function, C of Q. And when you've maximized your profit, and again we said maximize your profit around 60, you'll notice that that's going to give us the biggest distance. Because remember, revenue is how much money you bring in, and then this is how much it's costing you. So you want to find the biggest distance between revenue and cost. So where the cost is on the bottom, is on the top. So this is actually your profit function at Q. So what you see is that you don't really make a profit, much of a profit, if you pick any other value. But by maximizing your profit, you found that this is going to be the one where you bring in the most amount of money and it costs you the least. And that's the idea behind optimizing profit. Thank you.